Welcome back. This is the second lesson recording for IM1, January 26, 2021. Now that we have just finished reviewing how to graph a linear equations, we are going to be playing some fun math games. Okay, so you're going to be guessing the two numbers that I'm thinking of. So I'm thinking of two numbers, but there are some special conditions. Okay, when I add the two numbers, the sum is going to be 10. So visually I can represent this as the first number plus, okay, when I add means plus, the second number is going to be, the sum is 10. So the first number plus second number is going to be 10. So I don't know what the two numbers are. It's like it's in a box. Okay, but the second condition is when I subtract them, the difference is 2. That means the first number in the box minus the second number is going to be equal to 2. Okay, so what do you think? Pause the video and see if you can come up with a strategy or solution to make these conditions true. What are my two numbers? What's my first number in blue and what's my second number in yellow? I'm not going to give you any strategies because I want you to try. Okay, I'm guessing that most of you are trying guess and check method where you're putting in, okay, maybe if x was 5 and 5, that would become 10. Okay, so maybe the numbers are 5 and 5, but then if I put 5 and 5 here, 5 minus 5 is 0, not 2. So that doesn't work. Let's try a different combination. What if it was 1 and 9? 1 and 9 would work, that's 10. But if I take 1 minus 9, that's going to give me negative 8, certainly not 2. Okay, so keep thinking about those things and see if you can come up with a solution. Okay, we are going to revisit the solution in a minute, in a little while, I should say. Okay, we're going to bring it up a notch. Hopefully you had your solution. Okay, let's make it a little bit more complicated. I am still thinking of two numbers. When I add them, the sum is 1. But when I subtract them, the difference between those two numbers is 5. What do you think? Okay, pause the video and see if you can come up with the two numbers. Well, the interesting part is when I add those numbers, I get 1, but when I subtract, I get 5. How can subtraction lead to a bigger number? Well, the only way that's possible is if this number is a negative. That's my hint for you. Keep thinking, and the solutions will be revealed to you. But I hope you had some numbers in mind. Okay, so then I am going to bring up yet another notch. We are going to get really complicated here. When I add two numbers, the sum is negative 12.5. So visually, we can represent it as the first number plus second number is equal to negative 12.5. But when I subtract them, the difference is 3.5. Oh, the subtraction. Okay, the number got bigger again with subtraction. But when I added it, it's negative 12.5. Oh, so we're dealing with not only decimal, but we're talking about negative, positive, and numbers that are going to be bigger. Ah, my brain does not like this, and it's saying, I am confused. There must be a better way. Well, there is, and that's where systems of equation comes in. And it's for situations where you want to find two unknowns, that's two variables, and there are two separate requirements the unknowns have to satisfy. So we will learn in this unit how to model different situations as systems of equations and different methods to solve them. Okay, so let's get back to guess my number 1. So we're going to study a problem with a solution, and then we are going to find the general method and then use the method on complex problems. So we're going to start with, what works with a very simple type, and then we're going to bring the complexity up. So to begin, the first question was that two numbers that add to 10 and two numbers that subtract. The difference between the two numbers was 2. Okay, so instead of dealing with this unknown as a box with a question mark, we're going to be smart about it and bringing in our variable x and bringing in our variable y to represent the two unknown numbers, and likewise for the second requirement. Now that looks like a equation, doesn't it? So we have x plus y is equal to 10, where x is the first number, y is the second number, and x minus y is equal to 2. Now let's think about the possibility. So x plus y is equal to 10. That means if x was 1, what does y have to be? It's 9, because 1 plus 9 is 10. If x was 2, what does y have to be? One number plus 2 is 10, it has to be 8. If x was 3, what number does y have to be? It's going to be 7. Okay, so graphically, what I can do is x is 1 and y is 9. So I can say, I can put this into coordinates and say this is 1, 9, where the first number represents the x value and the second number represents the y value. So it's going to be right there. Okay, the second number 2 and 8, it's going to be 2, 8. 2 is my x coordinate because that's my blue, y is the 8, and 3, 7, and so on. 2, 8 is right here, 3, 7 is right here. Okay, what do you notice? Okay, if I actually kept on going, it will be 4, 6, and so on, right? So I can even put in another dot. Okay, why am I doing that? Because what I can do is, it's going to form a line. It's going to form a straight line. So I can join this and connect the dots and form the line. Okay, so then, all right, so that's what's representing the first equation. And in fact, if I convert this into y slope-intercept form, this is going to be, remember we want it to be y is equal to, that means we don't want the x. How do I get rid of the x so that we are just left with y is equal to? We're going to subtract x from both sides, so it becomes to the other side as a negative x, so it's negative x plus 10, and that's what we have here. Y is equal to positive 10. Well, my graph is not very accurate. It should be going through here. Okay, the y-intercept is 10 and the slope is negative 1 because it's going 1 down, 1 across, but it's going down. So this is the line. What about x minus y is equal to 2? Again, we can think about some numbers that work. If x was 3, y has to be 1. If x was 4, y has to be 2. If x was 5, y has to be 3. So I can represent that as some points, as corner points. Okay, say 3, y. So it's 3, 1, 4, 2, 5, 3, and 6, 4. Okay, look what happens when I do this. Again, it's going to form a straight line. Let's see if I can draw this straight line. Okay, so the blue represents the second equation, the red represents the first equation. Look what happens. Okay, we have where the two lines meet. Where the two lines meet, and that happens to be when x is equal to 6 or 6, 4. That means x is equal to 6 and that y is equal to 4. And that's what we have. The first number has to be 6 and the second number has to be 4. Okay, so this certainly works by graphing. Okay, let's consider the second problem. Okay, so we said the first two numbers, the numbers add to 1 and then they subtract to positive 5. So that means we can replace that with x and y's again, variable x and y's. And you have two equations, and we can start by graphing them, and you can use Desmos graphing calculator for this. So for that, what you're going to do is you're going to go to desmos.com. So if you just Google desmos.com, it's going to get you to the graphing calculator, and when you go to desmos.com/calculator, it's going to pull this up for you. Okay, and then from here you can type in x plus y is equal to 1. That's our first equation. It's going to graph it for you. Okay, so then I also want the x minus y is equal to 5. That's my second equation, right? So when you do that, look what happens. Okay, so when you do that, you have two lines that cross at an intersection. If I click on that, it gives me the coordinate of the two intersection, and I get 3, -2. And that's what I have here. Of course, you could convert this to y is equal to mx plus b form, because you know how to do that, and then graph it yourself instead of just using the Desmos, because that would be a good exercise. And the first equation becomes y is equal to -x plus 1. The red equation is -x plus 1, and the green equation is y is equal to x minus 5. You can see the y-intercept of -5 and the slope of 1, and y-intercept of positive 1 and slope of -1. Okay, so this tells me where the two graphs meet, where the two lines intersect, or two conditions are satisfied, is when x is equal to 3 and y is equal to -2. So that means the first number is 3 and the second number was -2. Now that's the first part of solving systems of equation. The second part is to verify, and this is really important. Do the two numbers add to 1 and subtract to 5? You're checking to make sure that your math is correct. Okay, so to do that, you substitute these values to your original equations, both of them, not just one, but you need to substitute it into two different equations, since we have two different equations to check. So x is 3 and y is -2, so x plus -2 is that 1, and yes, 3 plus -2 is 1, so it does check out. So I know that that solution works for the first equation. What about the second equation? Substituting that into this second equation, x minus y is equal to 5, so 3 minus -2 is equal to 5. Okay, so then that gives me 3 plus 2, that is equal to 5, so it checks out. So this is how I know that yes, those two are my solutions. Okay, so I would like you to take notes on this. So solving systems of equations graphically. To solve systems of equation, two variables with two requirements, you need to represent the two requirements, that means the conditions, using two equations, then graph the equations, and the intersection point is the solution. The x and y value is the solution. And then the second part is to verify your solution by substituting your solution onto the requirements equation. Okay, so the two equations that you came up with, you need to substitute the x and y value into both of them and to come up with a true statement, and check if the solutions make both equations true. Okay, great. I am going to continue with this in the next lesson recording.